Welcome to this video, which I'm going to construct a 2 proportion z interval by using a real-life application problem. So in this scenario, we're given that the company reported that of a simple random sample of 25,000 US television households, 13.1% watched the Academy Awards in 2020. In 2019, a simple random sample of 25,000 US television households found that 16.5% watched the Academy Awards. Estimate the difference in the proportions of all US television households that watched the Academy Awards in 2020 and 2019. So this is kind of different with all what we've done before. So the questions that we did in the past is all about one z interval, but right now we're doing with 2 proportion z interval. So you might be guessed we have to identify 2p in this case, p1 and p2. So p1 will be the proportion of all US households in 2020 that watched the Academy Awards, and p2 will be proportion of all US households in 2019 that watched the Academy Awards. So this is the state part. After this, we're moving on to the name, the procedure, and checking the conditions part, which you can see right here. So first of all, what we're doing, well, this is called the 2 proportion z interval, the procedure that we're doing. We're also doing a 99% confidence interval. So first of all, these are 2 independent simple random samples, which is true in this case. Second, is the sample size that we're dealing with less than 10% of the whole population? Well, it is true because more than 250,000 US television households in 2020 and more than 250,000 US television households in 2019. Last but not least, checking NP and NQ. So if we're dealing with a mean, we're going to check if it's less than if it's greater than 25 or greater than 20, depends on your textbook. But because we're dealing with proportions, we have to check NP and NQ. So because we have 2 p's, p1 and p2, so they each have corresponding n, which is the sample size. So when we're doing this, we are first doing n1, p hat 1. So remember, if we're doing with z interval, always use the p hat and q hat, and if we're doing with a z test, using p and q, because think about that, we don't know the population proportion. That's the thing that we want to find. So we only know the simple proportion, so we can only use p hat or q hat. So then if that's clear, then we can just set the corresponding values into the equations and get the each corresponding values, which all greater than 10. Checking the same conditions for p2, they're all greater than 10, which means we can draw the conclusion the sampling distribution is approximately normal. Moving on to the third part, which is the do part, the calculation part. It's also a little bit different than what we're doing. Is we first have to label p1 hat and p2 hat. Those are the values that came from the question, 0.131 and 0.165. So after we stated them right here, we're going to use the formula to calculate the difference of standard deviation. So remember, whatever you're doing minus or plus, for the standard deviation, you're always doing the plus inside the square root, because you have to first find the variance of those and then add them together, take the square root, and get the final answer. So this is the formula we're using right here, and we will get our final answer as this. And then this will be the difference of standard deviation of these 2 sample proportions. What we're going to do next is to plug this value into here, into this whole formula, and get the interval. So use p1 hat minus p2 hat. You can put a parentheses right here if you want, plus or minus z star times the standard deviation we just calculated, and get the confidence intervals, the intervals for this question. So basically that's it. And moving on to the last but not least part, which is the conclusion. What should we say in here? It's pretty similar to what we've did when you're doing one z one mean, one z interval for one mean, except in here we're doing with proportions, and we're doing the difference of 2 proportions. So the conclusion will be, I am 99% confident that the true difference between the proportion of viewers in 2020 and 2019 is between -4.2% and -2.6%. If you think that is kind of awkward, you can also change the format to be the proportion of viewers in 2020 dropped between 2.6% and 4.2% from that of 2019. So yeah, that's all for this question, and this is basically the format you will be using for most of the inference procedures questions, FRQs in your AP exams. So always remember the 4 parts and make sure to put your words into context, and you'll be fine.